In this video, I'm going to go over some eigenvalue shortcuts. So let's scroll up here. This is a homework problem that you did recently. And we already had some shortcuts here. Remember, we had a really long process that got us from this, or I guess this matrix A, into here. And then you go and you set it equal to 0, blah, 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 and you do this stuff. So what I'm going to do in this video is show you how to go directly from here to there. It's pretty quick and it's pretty easy, and I can actually prove to you that it works to go straight from these four numbers into the characteristic equation. What does that mean? We don't have to FOIL, we don't have to add numbers, we don't have to worry about negatives and messing it up, and then, wait, did I add something, right? We can just go straight from here to here, and then we can factor and go right to this, and it becomes a very seamless process. So, in order to show this to you, we usually have x, y prime equals some square matrix A times xy. Or I could write it as x vector prime equals capital A, where that's a 2 by 2 matrix if we're doing a 2 by 2 system or a 2 variable system, times x. And I want to focus on this A. So I'm going to let A equal A, B, C, D. And I'll show you, I'm going to actually go up above and I'm going to show you what the trick is. Watch. See the -3 and the -5? The numbers on the diagonal there? If I add those two numbers and negate them, I get my 8. I get my positive 8. Then, if I take the det of this matrix, right? Not the det of this one, but if I do the determinant of this matrix, I get positive 15 minus 24. What's that give me? -9. That's our trick. I'm going to show you why that's true. It's called the negative trace and then the determinant. This number is always the negative trace, and this number is always the determinant of the matrix A. So let's work that out. All right, so I'm going to do A minus lambda I, and I'll put my det sign on there. That is equal to det of A minus lambda, B, C, D minus lambda, which gives us, all right, A minus lambda, D minus lambda, minus B times C. And then if I FOIL this out, I get A, D, minus A lambda minus D lambda. That's the inner two, and then plus lambda squared minus BC. What's that give me? Well, if I write the lambda squared, it's always going to have a coefficient of 1. And then if I write minus blank lambda, what do I have in there? I get an A plus D. Notice that is the diagonal right here, the trace of the matrix summed together, or the diagonal sum, which is the trace. And then I get plus, right, AD minus BC. So this is the det of A, and this is the trace of A. So if I ever want to go directly from a matrix A to a characteristic equation, I can always go lambda squared minus the trace of A times lambda plus the det of A. And those things, as you do them over and over again, are going to become very quick and easy to solve. Let's try right here to see if we can get the characteristic equation in one simple step. I'll do this one. No, I want you to try this. I want you to hit pause and see if you can get straight from this matrix A into the characteristic equation. Hit pause. Here comes your answer. All right. It is lambda squared minus, all right, the trace is the sum of the pieces on the diagonal. 1 plus 1 is 2. Minus 2 lambda. And then the deep. 1 minus 4. What's that? Minus 3. And then that's equal to 0. And I can go from there. So if you take a look, it was this part right there that I gave you, and you jumped straight to there. So the only work that you would have to do for this problem after that is factor it, and then do your eigenvector work. So let's do the next one. All right, here we go. Number 2 from your homework from last night or whatever. Here's our matrix A. See if you can, in one step, go from the matrix A straight to the characteristic equation. Hit pause, do it. Here comes your answer. We get lambda squared. The trace is 2 plus 1. That's minus 3 lambda. And then the det is this 2 minus this 6 minus 4 equals 0. Boom. Lambda squared minus 3 lambda minus 4. Let's check it out top. Hey, look, it worked. We went straight from there to there. And then the problem becomes much quicker. Let's do another one. Okay, see if you can go straight from the matrix to the characteristic equation. Here comes your answer. It is lambda squared trace 4 minus 1. That is 3. And then negate it, I will get minus 3 lambda. And then this determinant, negative 4 minus 6, gives me minus 10 equals 0. Lambda squared minus 3 lambda minus 10 equals 0. Let's check it up top. Well, bam! Right from there to there. Skip all the messy work. Sick! I love it. All right, let's do one more. Bam! This guy gives me this matrix. Let's see if you can go straight to the characteristic equation. Lambda squared, oops, let me get a pen. Lambda squared, all right, negative 3 and 5, that adds to negative 8. Negate it, double negative, plus 8 lambda. And then I got negative 15, I have to do some scratch work for this, plus 24. Well, you got to think about those numbers a little bit, but eventually you get plus 9 equals 0. Bam! Done. That matches what we have up here for this one. So hopefully you see that our work for these eigenvalue problems, it's getting to be a lot smaller. And if you think back to when we did this with elimination and how long that was and how error prone that was, that I want you to realize that we've come quite a long way for solving these systems. Imagine solving this absolutely terrible system with elimination. You're going to solve for y and have like all these things over 4 and then like multiply by 5 and then, that's that. No, thank you. And then let me try to solve for x instead. Let me solve for x, move that over all times. Oh, man, like, no, thank you. I do not want to do that with elimination. But if I use eigenvectors, eigenvalues, and eigenvectors, I can just look at the matrix A that defines that system, pop straight into the characteristic equation, do a little bit of quick factoring, figure out what these matrices look like, and then find the vectors. And I think that at this point, finding the vectors might still be a little bit of work, but the more that we do it, the more you practice it, the better you'll get at it. So, hope these tricks help, and I will see ya soon.